Hello everyone and welcome to this session on Fundamentals on 3D Printing in Education. Today we will explore how 3D printing is reshaping the fashion and manufacturing industries and how it can be integrated into vocational training to prepare students for the future of work. By the end of this module, you will gain a comprehensive understanding of 3D printing and its applications in education, fashion, and manufacturing. You will explore the history and evolution of 3D printing, recognize its impact on industries, and develop technical skills in 3D printing technologies and processes. You will learn to design and prototype using 3D printing software, optimize educational models, and troubleshoot common printing issues. Additionally, you will understand how to operate 3D printers effectively and integrate this technology into vocational training and industry practices. By achieving these learning outcomes, you will be equipped with the knowledge and hands-on skills to apply 3D printing in both educational and professional settings, fostering innovation, efficiency, and sustainability. So let's begin. You might be surprised to learn that 3D printing isn't a recent innovation. It's actually been around for over 40 years. Its story begins in the early 80s, specifically in the 1981 when Dr. Hideo Kodama introduced a rapid prototyping system that used light to harden materials, a process called photopolymerization. Then just 5 years later, Charles Hall patented stereolithography or SLA. This is a method still used today for creating highly detailed 3D prints. The 90s brought us even more advancements. We saw the development of selective laser sintering or SLS and fused deposition modeling or FDM. These innovations made 3D printing more accessible, allowing industries like healthcare, automotive, and fashion to start experimenting. By the early 2000s, 3D printing moved beyond just making prototypes. It became a tool for actual production. Companies began using it to create things like prosthetic limbs, parts for airplanes, and even food. And today, 3D printing continues to evolve rapidly. We are seeing the integration of smart textiles, biofabrication, and design tools powered by artificial intelligence. Researchers are exploring ways to create environmentally friendly fashion, custom fit shoes, and even whole houses using 3D printing. Now, take a moment to think. What industry do you think 3D printing will disrupt next? Where do you see the next major breakthrough happening? The fashion industry is embracing 3D printing in ways that seemed impossible just 10 years ago. Designers are now creating entire outfits, shoes, and accessories using 3D printing. Unlike traditional fabric production, which often leads to a lot of waste, 3D printing builds items layer by layer using only the necessary materials. Personalization is a key trend. Brands like Adidas, New Balance, and Nike are using 3D printing to create custom made midsoles for shoes tailored to an individual's unique foot movements, improving comfort and performance. Meanwhile, new eco-friendly materials are being developed. Researchers are creating filaments from things like algae, silk proteins, and recycled plastics, making 3D printed fashion more sustainable than ever. One of the most famous pioneers in 3D printed fashion is Iris van Harpen. Her high fashion collections combine digital artistry with cutting edge design, showcasing sculpted garments that really push the limits of fashion and sustainability. Manufacturing is also seeing significant progress with 3D printing. Traditionally, making industrial parts required expensive tools and molds, making small production runs inefficient. But with 3D printing, manufacturers can now produce parts on demand, reducing cost and material waste. Factories are beginning to use 3D printing to create spare parts, eliminating the need for huge inventories and allowing for instant production whenever a replacement is needed. In industries like aerospace and automotive, 3D printing is used to manufacture lightweight, strong components that reduce fuel consumption and improve overall performance. Now, let's think about something you use every day. How could it be redesigned using 3D printing to be more functional or more environmentally friendly? To really understand how a 3D printer works, we need to look at its key parts, each playing a vital role in the printing process. First, there is the extruder. This is what heats up and deposits the material onto the build plate. It melts the filament and carefully places it layer by layer, building the shape you want. Depending on the type of printer, the extruder might have different nozzle sizes, which affect how detailed and precise the final print will be. Next, we have the build plate. This is the surface where the object is printed. It can be heated or not depending on the materials being used. Heated build plates are important for preventing warping, especially when printing with materials like ABS, which tend to shrink as they cool down. Non-heated plates are often fine for easy-to-use materials like PLA. Then there are the stepper motors. These control the precise movement of the extruder and the build plate along the XYZ axis. These motors ensure accuracy and consistency throughout the printing, allowing for complex and detailed designs. The types of filaments used in 3D printing vary depending on what the project needs. PLA is biodegradable and commonly used for general printing. ABS is stronger and more durable, making it good for functional prototypes. TPU is flexible and used for things like shoe soles or wearable items. PETG combines the strength of ABS with the ease of use of PLA, making it suitable for industrial and mechanical parts. Here you can find a figure explaining how a 3D printer works. Each of these parts work together to turn digital designs into real physical objects. Understanding how they work allows users to fine-tune their printing process and get the best possible result. The process of 3D printing can be broken down into four key steps. First, you need to create a digital design. This is done using computer-aided design or CAD software. Think of programs like Tinkercad, Blender, Clo3D, or Fusion 360. This allows designers to create detailed 3D models of anything from clothing and shoes to industrial parts. Once the digital model is complete, it needs to be processed using slicing software like Cura or Prusa Slicer. This software essentially translates the model into a set of instructions called G-code that tells the printer how to build the object layer by layer. The third step is the actual printing. Depending on what you're making, different 3D printing technologies can be used. Fused deposition modeling, or FDM, is commonly used for things like fashions, accessories, and tools. Stereolithography, or SLA, is known for its highly detailed prints and it's often used in jewelry. Selective laser sintering, or SLS, is frequently used in industrial production for creating strong and complex parts. Finally, once the object is printed, it's often not ready for immediate use. Most prints require post-processing such as sanding, painting, or UV curing to improve their strength and appearance. 3D printing is revolutionizing education by making learning hands-on. Students in fields like fashion, manufacturing, and engineering can now create and test their designs, making STEM subjects more tangible. This technology enhances digital skills, preparing students for careers in automated industries. By using CAD software and 3D printers, students gain practical experience in design and fabrication. In vocational training, they can create prototypes and custom items, bridging the gap between theory and real-world application. Global institutions are integrating 3D printing, shaping education in fashion, manufacturing, and digital fabrication. Case studies show students and researchers pushing boundaries, preparing for innovative careers. At FIT, students experiment with 3D printed garments, focusing on digital prototyping and sustainable design, preparing for a future of customization and efficiency. MIT's Digital Manufacturing Lab combines 3D printing with traditional methods, enabling students to develop and refine high-performance industrial components. UAL uses 3D printing in wearable tech and textile innovation, exploring smart textiles and interactive clothing. These examples highlight 3D printing's diverse educational applications. Hands-on experience with digital fabrication is shaping a new generation for designers and engineers, driving technological advancements and sustainability. Let's move from theory to practice with hands-on 3D printing exercise. We will apply our knowledge to a real-world scenario just like professionals in fashion and manufacturing. By the end, you will have functional 3D printed object demonstrating your design, optimization, and troubleshooting skills. First, choose your project. Do you want to create a custom jewelry piece or a futuristic shoe sole? Or perhaps a specialized tool or mechanical part for industrial innovation. What excites you most? Next, bring your vision to life digitally. Use 3D modeling software to create your object. For beginners, Tinkercad is excellent for simple designs. For more complex forms, try Blender. Remember the scale and support of your design as you model. After finalizing the design, we will move to slicing. Using software like Cura or Prusa Slicer, we will prepare the model for printing. This is where you adjust settings for detail, strength, and efficiency. Fine-tune the resolution for delicate fashion items or adjust infill for robust industrial tools. Now the exciting part, printing. Load the slicing file and watch your digital concept become a physical object. But like any manufacturing process, issues can arise. No matter your 3D printing skill, issues will arise, but every mistake is a learning opportunity. Troubleshooting isn't just fixing errors, it's understanding and refining your process. Knowing how to solve problems makes you a more confident creator, whether in fashion or manufacturing. Common issues include warping, fixed by heating the bed and improving adhesion, layer shifting, tighten belts, stabilize the printer, and reduce speed, under extrusion, clear clogs, match filament diameters, and adjust temperature, stringing, enable retraction and lower temperature, bed adhesion, level the bed and clean it. Why troubleshoot? In real-world applications, prototypes go through iterations. A 3D printed fashion collection needs test prints for texture and durability. Industrial prototypes are optimized before mass production. Instead of frustration, ask, what can I learn? Adjustments improve future prints. Every issue teaches about temperature, speed, materials, and calibration. 3D printing is an evolving process. Even professionals have failures using them to refine work. See mistakes as valuable data, bringing you closer to success. Looking ahead, 3D printing is poised to revolutionize industries in ways that were unimaginable just a few years ago. This technology is rapidly evolving, and with groundbreaking advancements, we are moving towards a future where products are not only customizable but also adaptive, sustainable, and increasingly intelligent. Another game-changing innovation is 4D printing. Unlike traditional 3D printing, where an object remains static after production, 4D printing introduces materials that can change shape, function, or texture over time. This could lead to self-healing garments, shoes that adjust to different temperatures or environments, or even furniture that reshape itself to fit different spaces. The implications for fashion, wearables, and industrial design are truly limitless. Biofabrication is another area of rapid progress. Researchers are already working on 3D printing human tissue, biodegradable fabrics, and living textiles. This has enormous potential for both medical applications and sustainable fashion. Imagine biodegradable, fully compostable clothing made from lab grown materials, eliminating textile waste entirely. On a much larger scale, 3D printing is also transforming the construction industry. What once took months or years to build can now be created in matter of days using 3D printed homes and infrastructure. This method not only reduces construction waste but also takes housing more affordable and accessible, particularly in areas affecting by natural disasters or housing shortages. Large scale 3D printing is redefining the way we think about urban development, sustainability, and rapid production. So why does this matter? These advancements means smarter production where materials are used more efficiently, reducing waste and energy consumption. It means greater sustainability as 3D printing enables circular manufacturing where old materials can be repurposed into new products. And perhaps more excitingly, it means complete customization where fashion, footwear, and even furniture can be tailored to an individual's exact specifications, improving both functionality and personal expression. As we move forward, we must ask ourselves, how will 3D printing change the way we design, manufacture, and consume products? How will these advancements influence industries beyond fashion and manufacturing? The future of 3D printing is not just about making things, it's about rethinking how we create, innovate, and sustain the world around us.